Hello and welcome back, Mr. Hein again. This time talking about average velocity from a velocity graph. So if you saw the previous video where we talked about average velocity from a position graph, this is slightly different. But what stays the same is what average velocity means. And it's important in calculus to understand definitions. And truthfully, that's how I, as a math teacher, I feel like I remember so much and I can help in different problems. Isn't because I memorize a lot of math, it's because I know a few definitions and I can apply it depending on the problem. Now remember the average velocity is defined as your change in displacement, which again is its distance, but it accounts for negative distance, because distance is only positive over your change in time. All right. So displacement, think about it as like position. From your final position minus your start position. That's really bad to see. Sorry, I'm gonna rewrite that. So displacement again is it's your final position minus your start position. Relative to where you started, where are you at when you end? Okay. So this is a velocity graph where the y represents speed of car in miles per hour and the x represents times in hours. Okay. Now we want to find the average velocity. Let's find the average velocity from 0 to the 10th hour. So we need to find the displacement here. Now, unlike a position graph, you can't just use this point because this point isn't a position. This is a speed, right? Now, how do we get a position? How do we get distance from a velocity graph? How do we get miles from a velocity graph? To get miles, remember that you have to do area under the curve. So to get the displacement here, so to find the change in displacement, we're going to have to use area under the curve to find, how far they traveled. So in this problem here, area under the curve, I break it up. I have what looks like a rectangle. I'd say a square, but technically that's not the same length. A trapezoid, another rectangle, and a triangle. So find the area under the curve here. The area from 0 to 10 is going to equal 2 times 20 plus 1/2 20 plus 50 times a height of 3. That's the area of the trapezoid. The area of this rectangle here will be 4, because that's at 9, times 50, plus the area of that triangle at the end, which is 1/2 the base, times the height. If I simplify that, that's 40. 70 over 2 is 35. And 35 times 3 is, 30 times 3 is 90. 5 times 3 is 15, so that's 105. 4 times 50 is 200, and that makes 25. Add all that up, and what we're at here is 305. 330 plus 40 is 370 miles traveled from 0 to 10 hours. Right? And that's great because now we can find the average velocity. So now average velocity is your change in displacement, which was 370 miles, minus where we started, which we're going to assume we started at 0, over the time, which is 10 minus 0. So then your average velocity here, 370 over 10, is 37 miles per hour. And that's how you find average velocity on a velocity graph, right? Now you're still using the same definition, but to get displacement, you have to use area under the curve in order to find the miles. Okay. Hopefully that helps. Now I'm going to keep going, which this is going to help with the later questions. If I was to draw the average velocity on this graph, let's see where it is. So this is average velocity. There's our answer in red. I'm going to stop the video, and I think there's more to talk about. And at 37, that's roughly, where is that? That's roughly here. So this right here was my average velocity over the 10 hours. Okay. So if you understand this graph, I was going 20 miles an hour for 2 hours, and then I sped up to 50 miles an hour over the course of 3 hours. And then from there, I stayed at 50 miles an hour, and then I slowed back down to 0 miles an hour at the 10th hour, right? Because I arrived at my destination, for example. And over that trip, over that drive, I averaged 37 miles an hour. Now, how many times did I go 37 miles an hour? Well, I went 37 miles per hour one time here at about 3.5 hours. And I went another time, because remember, I'm only looking at the graph here, don't get confused with my area under the curve. Right here, when I was coming back, when I was slowing down at about 9.25 hours. So I could say here that I traveled my average velocity 2 times during my trip. At 3.5 hours approximately, and at 9.25 hours approximately. Now, heads up, I use notation when I write these descriptions. If you take an AP exam, write it out in full words. They actually don't like seeing that, but when I do these problems, sometimes I don't think about the grammar. I just think about the math. So there it is. So that's understanding to figure out when did you hit your average velocity, which the question I asked me, and I'm not going to answer this for you, is will there always be a point in your trip in which you traveled your average velocity? Was there at least a moment in your trip where you will always hit your average velocity? Or is it impossible? Is there a situation when you do a trip and your average velocity for that trip, you never ended up going? Is that possible? Now, that's not an answer for today. That's an answer for another day, but something to think about. Hope this video helps. Good luck. Come to office hours if you need it.